Okay, this is example 313. So this is going to be explaining like a little bit faster way to find the inverse of a matrix using Gauss-Jordan elimination. So we can reformulate this procedure for finding the inverse of a matrix. And then for convenience, I'm just going to do for 2 by 2 matrices, and you just can generalize that to bigger matrices as need be. So we start off with A, is a 2 by 2 invertible matrix. Okay? And then I want to find the matrix that's its inverse. So I'm naming that matrix that I'm hoping exists. I'm naming it capital B. I'm naming its columns B1 and B2. And then I would hope that, well, in order for the matrix capital B to be the inverse, then A times the first column of B should be the E1. A times the second column of B would have to be E2 in order for it to be the identity. So last time I solved those separately. So you solve A augment 1 0, and we solved A augment 0 1, and solve those separately. And if you notice that you do a lot of the same, in fact you do exactly the same Gauss-Jordan elimination steps for both of them. And so a shortcut is that if you just augment both of them at the same time. So here's A, and then I augment E1 there and E2 there, and then do Gauss-Jordan elimination all at once, and then I get there, and then this makes B. B is then the matrix that I get once I've done Gauss-Jordan elimination of the whole thing. So it just is a shortcut. It saves you time. Plus, then you get like a matrix looking thing at the end. All right, so let's say some things formally then. So proposition 314, if A is an invertible matrix with inverse B, then any equation AX equals B is consistent and X equals big B little b is a solution. In other words, the solution to this, solving for X, is that X equals A inverse B. Okay, so proposition 315, the matrix A is invertible if and only if the reduced row echelon form of A is the identity matrix. So it's Gauss-Jordan equivalent to I. In addition, we find the inverse by augmenting A by the identity and finding the reduced row echelon form. So you just take your matrix A, augment the entire matrix, identity matrix, and then do Gauss-Jordan elimination. And if you end up with I, end up with I here, then the guy over here is A inverse. Then proposition 316, if A is an n by n invertible matrix with inverse B, then BA equals I, which tells us that B is invertible with inverse A. And then hold on. Yes, so the last line got cut off. The last line there is A inverse equals A. So that's proposition 316. So these 3 propositions you're going to need to refer to when you do the true-false homework questions. All right, I'm going to stop this video and then we'll start the activity next.